Let's see. Am I live YouTube? Alright, seems like I am. Okay, so let's try to do Advent of Code number 6. Yesterday I rage quit on the day 5 because I suck. Alright, Advent of Code. Day 6. Okay, yeah, I don't know. I will do the day 5 at some point in my life, I guess. Maybe this weekend when I have time. But I'd rather advance and have fun. Especially since I just managed to install Linux on this thing. It's a RISC-V computer and I was retarded enough to buy it. So yeah, I wanted to put PhotoPrism on it, but it's already been quite hard to just run Linux on it. Then it's even harder to run Docker on it, and then you have to make the Docker image compatible with RISC-V, which is a painful endeavor. Anyway, yeah, probably a bad purchase, but I did learn a lot. The ferry quickly brings you across the island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and the small island where the ferry has docked. As you try to figure out what to do next, you noticed a poster on the wall near the ferry dock. Boat race open to the public. Grand prize is an all-expenses paid trip to Desert Island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. As part of the signing up, you get a sheet of paper, your puzzle input, that lists the time allowed for each race, and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure to go farther in each race than the current record holder. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on the top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button... Ah, yes, I see. It's like Is it just what do you call that? Just a reverse squared function? Yeah, maybe I'm saying garbage, maybe. Like you hold, and at some point it's not worth it to hold it anymore. Toy boats allows the boats move faster if the button are held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and boats don't move until the button is released. For example, time, distance. This document describes 3 races. The first race lasts 7 milliseconds. The record distance in this race is 7 millimeters. The second race is 15 milliseconds. The record distance in this race is 14 millimeters. The race lasts 30. Okay. Your toy boat has a starting. So the first race lasts 7. Okay. And the one that is that lasts. Your toy boat has a starting speed of 0 millimeter per second for each whole milliseconds you spend at the beginning of the race holding down the button. the boat speed increase by 1 millimeter per second. Per millisecond. So, yeah, just checking again that I'm live because paranoia. Hop. Beep boop, 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 beep boop. Hop. Okay. That's alright. Hop. So because the first race lasts 7 milliseconds, you only have a few options. Don't hold the button at the... Don't hold the button at all. This is hold it for 0 milliseconds at the start of the race. The boat won't move. It will have traveled 0 millimeter by the end of the race. Hold the button 1 millisecond at the start of the race. Then the boat will travel at the speed of 1 millimeter per milliseconds for 6 milliseconds, reaching a total of distance of 6 millimeters. Ah, okay. So that's not like the race that already happened. That's like, okay, that's like the standard, the time standard for a race. Okay, and I guess we have to compute how long to hold the button for to get the optimal thing. Giving a boat of speed of 2 meters per millisecond, it will then get 5 milliseconds to move, reaching a total distance of 10 millimeters. That feels like how do you call that? A derivative exercise. Like, I know I'm gonna brute force it like a stupid programmer, but it feels like basic math should solve this, and doing the brute force approach will bite me later in part 2. Hold the button, yes. Actually, maybe it's a binary search. I mean, yeah, again, there is the smart math approach, but maybe binary search could be nice. And so here, for example, we can see that holding the button 3 or 4 milliseconds is the best, because you go the farthest. And then you have diminishing returns here. Since the current record for this race is 9 millimeters, there is actually 4 different ways to... okay, so it is a record, and so time... is the time allowed in that race, and distance is the maximum record of someone. Okay, that has already erased it. You could do for 2 to 4 minutes at the start. At the end of the second round, you could hold the button for 4. Okay, third race, he gives us the answer for us to figure out. To see how much margin of error you have determines the number of ways you can beat the record in each race. In this example, if you have multiplied these values together, you get... Okay, determine the number of ways you could beat the record in each race. What do you get if you multiply these numbers together? Alright, at least for this one, the parsing is very easy. Alright, package, bring, import. I wonder if you can do import like this in Odin, by the way. Core empty. You cannot. Okay. Import core FMT, main proc. And let's just open some random day so I can copy paste and go faster. Oop. Here. Up and example. And I have to copy paste xclip example. And let's just quickly, might as well get the puzzle input as well. Xclip input up. Okay, so yes, the real input is just an example, but with bigger numbers. undeclared OS like this. Println s Odin run this. What? Example 6. Oh, it's just input. What? Let's copy paste that again. X clip example. Okay. Main 6. It's bizarre that the 5 is before the 6 when I do this, but oh well. Maybe that's a bit too this because I am crouched. Okay, let's do this again. Yep, that's better. Then we need to do yeah, let's just do lines is equal to s no strings. I do not have strings. Split lines of s differ delete lines not strings. And then timeline. Lol. Did I really just said lol out loud? Yes, I did. 0 up like this, and distance line is 1, and then we can do we can do can I do timeline this, and then no, actually this we don't care either, and then we do timeline, and we do strings partition, and then we have timeline, and then separator is just this. And same thing for distance. Up. Oh, I guess we can just do this. Lines 1 like this. And then strings, is there a trim space? Otherwise regular trim is a cut set, but we only care about the spaces. Is there a shrink? How do you say shrink? Squeeze? No. Like in... No, there isn't. Split n. Contains pop byte, space, index any, trim left, join safe as suffix. Trying to find a split that, like, if there is multiple separators, it ignores them. Trim suffix, index multi. Whatever. Let's do trim. Does trim allocate a new trim? It does not. That's great. Trim space. Yes, that is good. And we do timeline. Does it return something? It does. Can we do timeline is equal to this? And distance line is equal to distance line hook. Println timeline. Let's see. Yes, that's what I want. And is there like space at the end? Oh, there is no, that one is added by println. Next, we want to do times is strings split times strings. Yeah, because we're gonna need to convert them to numbers after. Split yeah, sure. Split timeline by space and the same thing with distances. Up. Distance line like this, and then times strings. It's like this. And then we have a bunch of empty, and we want to just remove the empty. And I saw there is slice filter, and I'm curious if you use it here. Filter, let's see. But it's an allocator. That's a bit annoying. Can I remove? Whatever. Let's just filter it. Filter times strings, and we have here a proc. Not sure how to do this. S, which is a string, and returns a bool. And we do like return n s different than 0. Does that work? Pretty sure it doesn't. Let's see. Overview. Is there like not sure how to procedure type. A is equal to proc. That's what I type. Oh, I forgot the two dots again. I always think I'm in Golang. And so that's times like this, and defer delete times. Okay, and if I do times. Okay, except no, that's not okay. That is not okay, because that is not the time. I don't know. Isn't there really not a squeeze space text scanner build space is a ski space page is space trim right space trim contains couldn't cut equal fold expand tabs fields proc index join safe Levenstein distance partition prefix length reader replace all Hmm. Split a string into parts after the separator, retaining it in the substrings. Ah, okay, that doesn't help. Split byte, split lines, split multi. String case iterator. Split. String from to. Trim. Ah. Trim space, trim suffix. Okay, whatever. I won't spend a huge time on it. String empty, empty, and then times strings here. And let's just put that in a function, to be honest. Parse, numbers, line, number, line, sure. Proc, it's that's a string, and it returns a slice of int. Okay, and so we can put that here, that's fine. Line, and that's just, let's call that input. Inputs. Then we can trim space. Then we split strings with empties. Delete strings with empties. Yeah, that's not optimized at all, but we really do not care in this case. Strings up, and we just do strings with empties. Oops, with empties. Yes, like this, and it is line here. And then we do for we do a, so the return is make a slice of int that is of length same length as strings, and then we do for se in strings do ends I equal strconf atoy of s like this, and then we just return ends, and we defer delete strings because I think filter allocates a new slice, and then we do not need this, and we just do times is equal to parse number line lines 0, and distances is this, but 1. Let's print that. Okay, and let's print distances, and that's exactly what we want. Example. Yes, all right. Now. This only took me 20 minutes. What do we want to do? We want to iterate, so 4 time I. Yeah, there is no zip, huh? That's unfortunate, but I'm gonna check a second time because I think it would be useful in some cases. Zip. There is gzip, but there is no struct field zipped. I don't know. Slice. What is in slice? Binary search bytes from PTR. Clone CMP container equal dot product. Fill first. Get empty linear search. Map keys. Mapper. Max min. It's nice to know that there is a max min for slices as well. Rotate left. Simple equal sort. Alright, whatever. It's not important. Times, and then we do your distance is I. Is there an assert? Is there a built-in assert? Distance is equal to times. There is a built-in assert, that's nice. Declared but not used. And then we go for, let's say, how is it called? Like ms, I don't know, ms in 0 until max time, which is just time. And I have to go like this, I think. And what we do is what we do is let's brute force it in the first time and see. So the bot won't move and you will have travel to the end of the race. So now I need to compute like so it's let's call this try time. So it's time minus try time, and this is time to move. That's it. And speed is just try time. Yeah, it's a bit weird, but whatever. And then we do so 1 millisecond, then you will travel at the speed of 1 millimeter per second. So yeah, for 6 milliseconds. So it's just it will go for. Okay, so it's just a multiplication. So print ln speed times time to move. And let's break here. And then let's print that to check if I have the correct. Let's see. So it's 0. Oh fuck. 1. I have 10, 12, 12, and then there is a 6. 6, then 0 again. So 0, that's nice. Then there is a 6, then there is 10, then there is 12, 12, then there is a 10, then there is a 6, then there is a 0. Okay, that's exactly what I want. And we need just a condition, so Traveled millimeters is this, and if traveled millimeters is greater than distance, no, just distance, this, we can do that actually here, why not? We what? Need to multiply the things together. I mean, we can do break or something. We can stop searching, I think. So what do I do? Since the current record of this is in, there is actually 4 different ways. Ah, you have to count the different ways. Okay. Win possibility counts is 0, and we do win possibility count plus equals to 1. Expected 0 I said, and then we do here fmt print ln win possibility count. So 489, that's exactly what we want. And then we do we want to multiply them, and how much margin of error? I don't know, number of ways you can beat the record. Let's call it margin of error. They call it margin of error, and it's equals to 1. And then we do margin of error times equal win possibility counts, and at the end we just do margin of error. Let's see. Okay, let's run this on inputs. Up, inputs. Let's copy paste this. Up, 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 up. Is it good when it's slow, or is it okay? That's good when it's slow. All right. Part 2. Let's clean that apart. It's fast, I think. Yes. Actually, yeah. I think it's slightly slow because I'm doing a for loop like a stupid person. Actually, yeah, no, shouldn't be 4 times. Okay, maybe it's just compile time. Never mind, it's fast. Alright, part 2.